Hello and thank you for contacting Wave. I see from your clinical request you're struggling with comfort issues with this patient, and based on the prescription and the fact that it's keratoconus, he may be also struggling with the clarity with this vision, the vision. So let's talk just for a moment about the design. Just a general comment, as wonderful as Wave is, I find that sometimes even the best designed lens with the Wave technology sometimes struggles to perform perfectly on a keratoconus eye, and it's just no rhyme or reason other than that they're difficult corneas and the rules go out the window. But with that said, looking at your design, I see you chose an RSIM design, and I see why you chose that because this cone is relatively centered. But one of the problems that you'll run into, keep in mind that the RSIM is sort of an average across the whole cornea. So if you're in this superior meridian, you're going to have a lot flatter cornea than the central part, which is a lot steeper. So somewhere you'll end up with a lens halfway between there. And since this cone is ever so slightly decentered inferiorly, with the way the lens is probably going to want to ride to hug that cone, thus riding kind of low on this patient. So a couple things you want to do. You want to get this lens to center as well as you can, and what you really want to look at is the landing zones on the lens. So if I bring your design up, we'll look at your landing zones, which of course is between the blue and the pink dot. And if you go around each meridian, we'll start at the 3 o'clock and work our way up, you'll see that around the 12 o'clock you're relatively aligned. If we get over to the 10, we got a lot of clearance, still a lot of clearance at 9, down around 8 we got a lot of clearance, still clearance down below. 4 o'clock, and then you've got starts coming back in, almost a downturner there at about 3 o'clock from the blue to the red. So you'll see that we don't have great alignment out here. So what you want to do is find a way to maximize this. So quite often if I get a design that isn't looking that great on RSIM, even though you're relatively centered, I would probably just switch right over to freeform in this patient. Now if you go freeform and let that redesign, I'll show you what did a quick little mock-up of that, just using the same parameters and doing a freeform design. You'll see that now you're relatively well lined in all the meridians between the blue and the pink dot. You'll get a little clearance, a few bumps up inside the red just because of the topography, but for the most part you've relatively aligned this peripheral cornea. Now if the lens is a little bit on the snug side, an easy trick is to flip over to tangential. Tangential sometimes gives us a little truer representation of the peripheral cornea. And another tool I like to at least look at, if you recall in this a quad view down at the lower right hand corner of the Wave software, the lower left is the back surface of the lens and the lower right is the Wave interpreted topography. So in theory, if you could get those two to look very similar, you're going to have a back surface of the lens from the left hand lower corner that would be very similar in shape to the topography in the right lower corner. And so if we flip in, I did another design here where I flipped in a little bit of the S factor, about -0.05, redesigned the lens, and you'll see, lo and behold, now I've got a lens that looks virtually identical in the two designs, lower left. And now if we kind of go around and follow each meridian, you'll notice that if we start at 3 o'clock, we're pretty well aligned. You come down to 6, all the way around 9, all the way around 12. So now you have a lens that's pretty evenly aligned with that corneal line, especially in those landing zones. And I think this lens would have a much greater chance of centering more consistently. It'll probably be less noticeable in your patient's eye. Just a comment on power, as you know, because of the keratoconus, that its cylinder is probably not a true refractive cylinder, more of a anomaly because of the warped cornea. So you could certainly start with that refraction. Sometimes what I like doing in these patients is before I as part of my fitting process, put on a spherical RGP of known parameters and get an over-refraction from that. And then I go down here to the tools in the lower left-hand corner, hit trial lens data, enter my trial lens data as well as the over-refraction, hit continue. If I really am questioning this corneal cylinder, sometimes I'll just start off with nothing in these boxes, just take it all out. Just set them all at 0. Design the lens. I get it down there. Just get the lens designed, and once the lens is designed, then I still added my over refraction power here, and that will sometimes help you if you're struggling getting the powers to work properly. Well, I hope you find that helpful. I would do the same thing, same basic idea on the left eye. I wish you well at this case. Again, these keratoconus cases are very difficult sometimes and are not very predictable in any way, shape, or form. But it sounds like you have you're on the right track. So good luck with that. Thanks for contacting Wave Support, and have a great day.